So the material from the second organic structures worksheet is well beyond the A-level content. So therefore, instead of having a worksheet of my questions and then later on a worksheet of A-level questions, I thought we'd have two of mine. One relatively straightforward, the other one much more challenging. If you can do the first one, you should be happy. If you can do the second one, you should go and read chemistry at university because it is obviously your great talent. Anyway, draw the following conformations: 1,2-dichloroethane. So let's draw 1,2-dichloroethane. Label as eclipsed, staggered, anti, or staggered gauche. So what I'm going to do is I'm going to look at it down the carbon-carbon bond from this direction. So I'm going to have the green carbon in front that has a chlorine and two hydrogens, and then the black carbon at the back, and I can't see the black carbon, but I can see the two hydrogens and the chlorine attached to that. Now I always start, just out of preference, with the completely eclipsed. So here's the front one in green. Front carbon there, green circle with the green bonds going to chlorine, hydrogen, hydrogen. Then again, you can't see the carbon at the back there, but you can see the chlorine that is attached to it and the two hydrogens that are attached to it. And as I said, I've started with the completely eclipsed version in which the back chlorine is right behind the front chlorine and so forth. So this is drawing the completely eclipsed. Now let's rotate it by 60 degrees. So we're going to leave the front the same, so you can see the green chlorine, hydrogen, hydrogen there. But now this chlorine that's at the back, I've rotated by 60 degrees, so it's sticking out like that. The hydrogen that was at the back here, again rotated by 60 degrees, so now it's down the bottom. And the hydrogen at the back here, rotated by 60 degrees, so it's sticking out there. So this is obviously a staggered conformation. Now let's rotate by another 60 degrees. And so now again, leaving the front the same, but now this chlorine at the back goes by another 60 degrees. So now it's behind this green hydrogen right there. The hydrogen here rotates by 60 degrees, so it's behind this green hydrogen. And this hydrogen rotates by 60 degrees, so it's behind the green chlorine. So obviously now we're back to an eclipsed conformation. Rotate by another 60 degrees, and we get this. So now the hydrogen that was here rotated by 60 degrees back there. The chlorine that was back here behind this black hydrogen rotated by 60 degrees, so it's there. And then this hydrogen that was here rotated by 60 degrees, so it gets closer to the green chlorine there. This is obviously a staggered conformation right there. Now I'm going to be kind of lazy here, because if I was to do another 60 degrees, well then I'd have this chlorine behind this hydrogen. That would essentially be this same picture, but just reflected. So I only need to do the 3 rotations of 60 degrees here for this nice symmetric molecule. Now of course, if things are different, if you didn't have 2 chlorines here, but you said a chlorine and a methyl, then you'd have to keep rotating. Now before I finish, of course, I've got an eclipse that I started with, another eclipsed here, but these two staggered are actually different from each other. Okay, in this one here, the back chlorine is only 60 degrees around from the front chlorine. This one here, the back chlorine is 180 degrees around from the front chlorine. So of course we call those gauche and anti. Anti meaning exactly across from, gauche meaning to the side of, essentially, I believe is probably the best way to interpret that. So anyway, there's the conformations: 1,2-dichloroethane. Same idea as that of butane that we did in the movies. It's just instead of 2 methyls, we have 2 chlorines. So some naming, name the following compounds using trivial group names if needed. Again, I think it's important that you know these trivial names. First of all, they are allowed by IUPAC, but even more than that, an awful lot of chemists will use them. So we'll start off with this nice little molecule here. So first thing, find the biggest ring or chain. Well, obviously the biggest chain is this one here, which has 1, 2, 3, 4, 5, 6, 7 carbons. So that's a heptane. What's left is this funny little sticky out group here that I hope you recognize as being a tert-butyl group. And that tert-butyl group is on the 1, 2, 3, 4th carbon. So that makes it 4-tert-butyl heptane. Now we'll look at these cyclohexane here. So again, biggest ring is obviously this 6-membered ring, the cyclohexane. I kind of gave that away, didn't I? We've still got an ethyl and a methyl group. So this ethyl, let's say this is on carbon 1, which makes the methyl on carbon 2. Now, that would be as far as you would go with A level, but of course we know that because you can't just rotate at will around bonds in a ring, these actually have geometric isomers based on whether these groups are on the same side or opposite sides of the ring. Now, when we look at this particular ring here, we see that both of them are above the ring. So the ethyl is sticking up from carbon 1 on the top with this hydrogen, an equatorial hydrogen below, and then we look at carbon 2, the axial hydrogen is below, which means the equatorial methyl is above. So both of them above the ring, therefore they're on the same side, so that makes it cis. So putting that all together, we get cis, 1 ethyl, 2 methyl cyclohexane.